This model was created using a shoebox, and each of the characters in the story is attached to a string, and in order to move them, you just take the string that's on top of them and pull them across. There are holes in each of the sides so that the strings can move. In the center is the library that is described in the story, and there's the ladder that Joe knocks down as he's running across. And this is Joe, and that's Maria. And as you can see, there is a diagram of what we use to solve the problem drawn out. And it's easy to manipulate by pulling on the string that is tied at each end around the box. For the first part of the problem, we know that Maria is moving east at 20 feet per second, and she is currently 300 feet away from the library. And we know that Joe is moving south towards the library at 15 feet per second, and he is currently 500 feet away. We're going to use the variables J and M to represent the two characters and C to represent the distance between them. We do need the length of C, which can be solved for using Pythagorean theorem, to get 583 feet. This will be used later in the problem. For this related rates problem, we come up with the equation J squared plus M squared equals C squared. And in order to continue, we need to take the derivative in respect to time to get this. We then plug in the variables that we know. We know that Joe is 500 feet away, and he is moving at 15 feet per second, and it is negative because he is moving south. And then we plug in Maria's numbers, knowing that she is moving 20 feet per second, and she is currently 300 feet away from the library. And we know that the distance between the two, which is solved for using C, is 583 feet. And we are solving for dc over dt, and the value comes out to negative 2.57 feet per second, which is the rate at which the two are moving away from each other. For the second part of the problem, it states that Joe is running at 4 feet per second into a 20-foot ladder that is 15 feet away from the wall. We are solving for the rate at which the ladder moves up the wall when Joe hits it. To start this problem off, we start with a squared plus b squared equals 20 squared. A squared being the distance away from the wall, b squared being the distance the ladder is moving up the wall, and 20 is the length of the ladder. We then take the derivative of that above to get 2a dA over dt plus 2b dB over dt, which is equal to 0, because the derivative of a constant is always 0. And we took the derivative in respect to time. We then plugged in the values. 2 times 15, which is the distance the ladder is away from the wall. Negative 4 is the rate at which Joe is moving. And then 13.228 is the length of B, which was solved using Pythagorean theorem. We are solving for dB over dt, and again, 0 is the derivative of a constant. And when we solve for dB over dt, we got the value 4.53 feet per second, which is the rate at which the ladder is moving up the wall.